an array of size n. They like take turns to do these operations with Alice starting first. Then Bob will like be the second player, and the player who cannot operate will lose. So at first, a variable mx is set to 0. In one operation, a player can choose any index such that ai greater than equal to mx and set mx to ai. Then set ai to 0, and we have to check if Alice can win. If there is a possibility, Alice can win. Okay, so let us take some of these cases. Uh, so let's take a simple one. We have 2 1. So what will happen? What if Alice goes first? Will she choose 1 or will she choose 2? Which is advantageous to her? Yes. So yeah, so the like this is kind of a greedy approach, you might think, right? Initially, because if I always pick the maximum number, I'll win because no one can like replace me, right? This can be an one thought process. But what if there are more than one, right? If there are like suppose let's say two. No, not necessarily. This in this case you might get a wrong answer, right? For example, let's say we have uh 22111. Okay. So uh according to your logic, if like since frequency of the largest you said, right? Acha, like one. It is not necessary that it has to be the largest. Like Alice can win in even this one as well. Yeah, exactly. Like you can generalize this part actually. Let me just write in this part. Suppose if one processes, Alice takes this one, then Bob will think, okay, he has two options. Either he takes this or he takes this, right? So if he takes this, uh, then what will happen? These two are gone, and Alice has these two options. Either she takes two or she takes one. So if she takes one, Bob only has to pick two. Like that is the only option available to him. And finally, Alice will pick two. Like let me draw this cleaner. Let's say we have one, two, and two. Right. So Alice starts with this one. Then Bob has an option among all these remaining sets. So let's say he goes with uh, this one. Right. Because if Bob chooses this one, Alice will choose this, and Bob will no longer have any move. Is it clear why this is like not feasible for Bob choosing two in the second step? Others? What about the others? Is it clear if okay? Who else is there? Let me just check. Prithvi and Shagupta. Is it clear? Uh, is it clear to you guys? Why? Okay, sure. Then now since we have determined that choosing two in the second step is a wrong, like not feasible for Bob, what he'll do is instead he'll choose this one. He'll choose a one, right? Then again, what will Alice do? If Alice chooses this like this particular option, she will lose just the same way Bob lost right now. So she will also choose this one. Now finally we have these two options, and it is Bob's turn. Whatever he chooses, Alice will win, right? So we can like have to print yes. Okay. But what what about some other cases? Let's go through some other cases, right? 1, 2, 2, yeah, 3, 3, 4. Okay, 3, 3, 4, 4. 3, 3, 4, 4. What happens in this? Alice will move first, right? So she can either choose 3 or she can choose 4, right? So if she chooses 4, let's say, Bob can only choose 4. So Bob will win, right? Because Alice can no longer choose either of these. Because what was our condition? Once mx is set to some a of I, it can only be replaced if your new a of j is greater than or equal to a of I, right? This is the only possibility. And since these are our only options, Bob will lose. So it is not feasible for him again, right? So he will go for 3, right? This will be Bob, right? And now Alice will choose one of these. And finally, Bob will choose the last remaining 4, and Alice will no longer have an option. So Alice will lose. So what you will actually observe from this is that in case there is like this even number of like elements, like you have something like A B B, Alice will always lose. So what does Alice actually require for a winning strategy? As we like if you notice from this particular question, we had both even frequencies and odd frequencies, right? So we have both of these kinds of frequencies, right? Yeah. So what Alice actually needs to win is even if one element has a odd frequency, right? So this odd frequency is our winning condition. Because how can you look at it? If like there are even, suppose you have A and B, and you have like a C. Whenever you choose this one, choosing this one basically nullifies your winning position, right? Because basically both of you reach the same state, and the next time it's your turn, like if you're Alice. So that's why to like skip your turn of ending, like you end up being the person who cannot make a move, you need this one, like odd frequency. Basically, you just need like one element to give you like an escape option. So that is the whole concept about this question. I hope it's clear to everyone. Is it clear? So like you can write in the chat box. Then I'll just show you guys the code and then we can move ahead. Okay. Then this was my submission. As you can see, I just like took a map, took my input, added it to the map, and here if like basically just have to check if any of these is true, like if any of them like the frequency is odd, you just put true and you come out of the loop, you print your answer. This is pretty much all there is in the question, right? So let's move to the next question. and -1 in the rest of the cells. Like, I think instead of like if you want to actually maximize that, instead of -1, you can like try with -1 plus 1, like something, a sequence like this. Basically, this will be then like something around 0 or 1 something. Because -1 just like completely makes it like minimizes the thing, right? Let's see. Okay. So the question initially was a bit confusing, right? So basically, do you guys know what a prefix or a suffix is? Okay. So basically, they've asked us to like find some, like they've actually provided us with some index, which is for our prefix, and we have some y, which is like our suffix. Like this particular region and this particular region, we have to maximize our score. Like these two should be maximum. So this is actually a implementation based question. I'll actually explain it with my code itself. So what, like even I made some mistakes in this particular question. So what you will do is if you have just like initialize as like Shonak said, you take this vector and you have some, suppose here you have your y and here you have your x. X is always greater than y. They have like provided this to us. Okay. So basically you just fill this particular area with ones. So like if this part is like -1, like initialize everything with -1. Okay. So if everything is -1, you will have some value, but this will like this particular area, wherever y will end, like end, or wherever x will start, uh, it will be like +1 is the maximum you can get, right? Your options for AI are like AI lies between 1 and -1. Is it clear why I said +1 should be at your index? Uh, what about others? Like at least you can write in the chat box. So like we can also know if you're understanding that part. Okay. Basically the thing is if you like have any array, if it's just -1, -1, -1, even if you have a +1 here, okay, the prefix here is still always going to be less than the prefix till this point, right? That is like your main observation point. Yeah, because if you like x equal to it, okay, yeah, okay. So like that is the main observation. Even if you have something like, uh, if the whole thing is -1, that does not change your answer as long as this is greater than everything here. So that is your main observation in this particular code. Like you don't actually need a lot of prefix, suffix. So what can we do here? Okay. So what I did was I basically as y is less than x in my array from index y to x, I made everything 1. Okay. I initially made everything -1. Everything was -1. Okay. And I made everything here 1 because then the score will always be maximum wherever it starts or end. Okay. According to our definitions. Then what I did was, since I have to maximize my score, like this is one based indexing, so you can adjust it according to like whatever suits you. So just start toggle, like if you have some area, like what you will do is -1 +1 -1 +1. So this, like, your sum is like minimum. If you just for example, if you take something like -1 only, it will be like always less. And if you take +1, it might turn out to be greater than your like prefix for some -1 here. Okay. So it's better if you like just like -1 +1 is like a better option relatively. So you just fill it with -1 +1, like using this code. Similarly, you do it after x plus 1. Like we have our x here, right? So do the same thing with this plus minus plus minus. Okay. And this will like minimize your whatever sum there is. So that is pretty much the logic behind this implementation. Like that was my particular logic. Uh, what about you guys? Was there some different approach? Because it is like as they like even though the problem states there could be like multiple arrays that satisfy this condition. So if you had a different kind of approach, you can share with us. We'll be sharing these codes, so you don't have to worry about it right now, but definitely try implementing it. Is it okay? Is it clear to everyone? Okay. What about others? Okay, sure. Shaunak and Prithvi, Shagupta, you guys understood, right? Okay, then for let's move to the Atcoder part. Achha, wait a second. I first wrote the sum of elements and performed the. Okay, actually, I think this was like a greedy kind of question, as far as I remember. Like you can try it again. This is like I'll have to check once as well. Okay, like we'll share that code with you if that is required. You try it once. If you still face any issues, we'll like discuss it. Okay, like it is like usually if you have like a diff to C, you can like take some time to solve it. If you still face any issues, you can ask us. Is that fine? You pass the samples. Okay. First stored the sum of elements, then perform the math. So what error were you getting? Was it like TLE or was it something did not pass pretest 4? If it passed till pretest 4, maybe you might be missing some edge cases. Okay. Like usually if there is something like that, it fails pretest 2. You might have also seen it. But maybe you are like missing some edge cases. Like did not pass. Like you got a wrong answer, right? Or was it like time limit? Okay, wrong. So, like, if you pass test case 3, then I don't think there is much of an issue with your logic. But, like, try again. There might be some edge cases that are, like, currently missing. Okay. Like, you can share your code with me or in the group. We'll look into it. Okay. Okay, sure. Then let's move to Atcoder. Okay, this was like a if else wala state question. I'll still discuss it, but basically they've said ki you have some R. If R lies somewhere between 99 to 1, you have like just one this. Okay. If your R is greater than this range, it's somewhere like 100 to 299, you will have two of these. So, and like similarly, it is till 399. Okay. So they've asked us uh, at my current level, for some current level I am at, how many more points do I need to have like a boost to like gain one more? I want one more this cap thing. Okay. So this is a pretty easy question, I think. But like, if was there someone who's had some issues? You don't need to do 100 minus n mod 100, but like, okay, yeah, that is also a good approach. You didn't have, acha, no, but you still need 100 minus n mod 100, right? So you need, right, like wrote all if else, or you wrote something else. This is like a general formula for all, right? Ah, yeah, okay, yeah, this also works. This is a good one. Okay, yeah. And you can like write two or three if once if like it is r is less than equal to 99, you will subtract from 100. Else if it is less than 199, I think, you will subtract from 200. Otherwise, you will just like subtract from 300. But as Shonik said, since you only need like a difference, you can just 100 minus r mod 100. This will also always work. This is a good solution. Yeah. Like, is that part clear? This is like a if else question. Is it clear with everyone? Did you guys have some other approach to this one? You can share it with us. Like, this was a good approach. Acha, how many of you guys gave today's Atcoder? You can like raise your hand that ah, okay. What about others? Guys weren't able to give today? It is fine. We'll still like discuss the questions. You can like lower your hand. We'll be I hope first question is clear. We'll be moving to the next question then. Is that okay? Okay, then I'll move to the next question. Yeah. So next we have, though there are some interesting names. So there were like multiple approaches for this question as well. Let me just open. Yeah. So basically, they told us that there are n number of people and they all have hair. Okay. And it has some length L of I. And each day, this L of I grows by one. Okay. Like their hair grows by like one, some unit. Now we want to find out that how many people have hair greater than a certain length P. Like this count we want it to be P. Okay. Like number of people should be greater than equal to P. So so basically they asked us how many days should you wait so that you have P people at least who have hair greater than or equal to your T. So this is the question. Is the question clear? Okay, yeah, this is also a good approach. So t minus n. So did someone else have some like other approach of this particular question? Like the main observation is like even if you have t minus a of I, like if you consider like hair growth in like descending order, because this is like the minimum time you need, right, for p to grow. So you have t minus a of I, but the rest of the a of like I minus 1 to 1, this will also like increase by 1 that day. So keep this in mind. Okay. The code, what I did was that, where is it? My submission. So yeah, basically, I did an initial check as to how many had greater than this length t initially. If I found that p people already satisfied it, I'll just print 0. Otherwise, I took a difference variable, which was basically how many more people I need. These many people I need. Okay. So what I did was, I'll just like sorted this in descending order, and then I run a loop. If my like a of I is already greater than equal to my, what, let's say, what was it, t, I'll just continue. I have already calculated like consider them initially, right? And I take an answer, and what is stored in this answer, t minus a of I, like how many days I needed. But what is missing is previously how many days I needed, right? I also need to take account of that. So what I did was I just like made a previous equal to 0 thing. Okay. And I kept account like how many people I have like reached. Okay. So what I did was AI increased by previous. Like if initially it was AI, instead of increasing in place, I just like AI minus previous. Like whatever increase we required that day, in those many days, the other hair also grew. So like it became AI plus like the whatever the cost was on the previous day or for like the previous person. So I just kept adding it to my previous. Previous became my new answer, and I kept increasing the count. Whenever the count increased the number of people I required, I would increase this, like break the loop, and this would be my answer. Is this approach clear? Everyone? Okay. Then did you guys have some other approach or some other thought process? We can also consider that. Like Shonak had like he stored all of this in a vector, right? So that is also a good approach. Okay, then we'll like move to number C then. So see if you look at this particular line, you will see like 10. like less than equal to 10, n and k. So do you guys remember how many iterations you can like pass when like you have a, let's say, during a contest, how many iterations like can you pass with your constraints? Like what is the order? 10 to the power? Not 5 actually. It's around 6 to 7. Okay. Maybe even more, but not a lot. Okay. Not like 9 or something. So you can maybe best case you will have maybe till 8, but consider it to be 6 to 7. Okay. So how much is 2 to the power 10? An approximation? It is, I think, around 10 to the power 7, right? Or how much is it? So yeah, around that 1000, right? So it will easily pass. And if since n and k both are like less than 20, so you can like just do a brute force for it. You just generate all the strings and you will do just one thing. You'll just check if they are palindrome. If they are not, you increase your count. This is all you had to do. Okay, but the thing issue most of you might have faced is it will be to how much? No, it won't be 26 to the power 10. Why will it be 26 to the power 10? You don't have to consider all the letters, right? You have to consider a string only, right? Like you don't have to consider all the characters. You don't your like string length itself is max to max it goes till 10, right? You just don't want there to be like a substring of size k. What I'm saying is basically that you can just this you can complete this check and you can just generate all the strings in your set and you can like solve it easily. Like we can just go through the solution. So basically what I did was I just took my string, I sorted it, okay, and for like you just define a window of size k. How many of you guys know about sliding window technique? I think you might have heard of it. Have you heard about sliding window? So generally, you might see it in arrays and some other question. Like I think it was in the previous week's Atcoder as well. So basically, they usually ask you like if suppose I'm talking about an array. So I want to know if what is like the maximum value in this window. Like if I have a subarray of size k, what is the maximum value or something like that. You don't need to find the answer in all of it. You need to find an answer in like a small subarray. We'll like share the resources for it. You can like study it further. It is a pretty popular technique. So what they've asked is that I don't need to find if the whole string is a palindrome. I just need to find if the substring of size k is a palindrome, right? If I can make a substring of palindrome k for any particular combination, you don't have it does not have to be like whatever they have provided. It can be anything. Okay, so that is what you have to do. You just like sort the string. That's it. 1 second. You just sort your string, and what you'll do is, uh, while you're like, actually this is like a this function, STL function. You can like in C++, in other languages I'm not sure, but in C++ there is this function next permutation. It will generate all the possible like a permutation. Like some, if you have something like this, it will give you this. You can just like keep making it. This function does it for you instead of you having to manually do it. Okay, so I used that and generated all the substrings, and I just had like a window. For example, what I did was I'll just like run a loop from 0 to I less than like n minus k. Because if I have a string A, B, C, D, E, F, this whole thing is not like a let's say a palindrome. But if I have k equal to 2, like this is the substring that I'm checking for, this is a palindrome, then I'll move this like my window to here. So AB is not a palindrome. Then BC is also not a palindrome. And CD is not a palindrome. DE is not a palindrome. And EF is not a palindrome. So you have to just like slide this. We are just like sliding this from here to here to here. That's why the name sliding window. You can like learn about it. There are a lot of resources available online. So I just like ran this particular loop and I checked if my current substring, like the substring that I have, if it is like a palindrome or not. If it is a palindrome, I will just uh, break. I don't have to do anything. I have found like an answer, and I'll like insert it into my final thing. Like what are the possible combinations that I can get, and then if I find a palindrome, I'll be like, okay, I don't have to check anything further. I found a palindrome. I won't do anything. I'll come out of the loop. Okay, so that is basically the implementation part of it. Uh, You just have to brute force the whole thing. Some of you guys have heard about backtracking, things like that. This is like a brute force approach. You generate all the possible substrings there are, and you actually check if they are like, if it is possible to, let's say, if this particular string is a palindrome or not, or if it has a palindrome of size k or something. So you can ask these questions to yourself by like sliding. Okay, so is that clear? Like what we did, there was like this was the only thing that you had to do. Just like generate all the strings and you check if any of them is a palindrome. That's why the like constraints also were pretty lenient. Like 2 to 10 is like not much, right? So yeah, I had that. Then I think the fourth question is also a string question. You can it's like not feasible for anyone to actually generate all the possible substrings in this case. Like they have asked you to like for a number, but actually use a string, like use a string of length 18, something like this. And like one pattern that you will observe is you have 0, 1, 2, 3. These are all palindromes. You guys agree, right? Single digits are like palindromes. Yeah. So what are the like next possible palindromes you can make? 0 will remain like that. You'll have 11, you will have 22, you will have 33, and like this you will have 99. Next, what you will observe is you will have 101, like some possibilities. 101, you will have 111. you will have 121, and you will have 131, and you will have 191, and like this you will like make for 3 digit, 4 digit. So you can just like take this as a base, then this, then you repeat it, then you repeat this, then you repeat this. So you like try to form it using that. I'll like suggest you solve this question by yourself, plus like it's getting pretty late. And like for E also, I'll give you guys the idea. E is like a BFS based question. It is like a standard BFS question, like breadth first search. You will learn about it in graph. We have not discussed it yet in our classes, but if you want, you can like learn about BFS. So yeah, that is pretty much it for today. 2 into 10 per hour. I think it was more like 990 and things like that. How many were there? There were nine of these. There were how many? Nine of these. You just count how many like length. You just check like if you have a 1 digit palindrome, 2 digit palindrome, thing like that. Yeah, from GP, right, right, right. Okay, yeah, you can do that, but just like I think the best time complexity you can get is something of order of log n, because O of n won't like you can get an idea from these constraints always. Okay, in contest, always like check the constraints. You'll like get an idea of your approach. For example, 10 to the power 18, you can't solve it with O of n. Okay, so what is like the next one thing that you can get? O of root n also won't pass because that is like what, 10 to the power 9. So you have to go smaller than that. So keep those things in mind, and you can just like solve all these questions later as well. If you face any particular issue, we can solve it today. Yeah, oh, yeah, you can solve it accordingly. That is not an issue. 9, 9, 10, 90. Yeah, you can like solve it like that. 10 to the power 9. Okay, yeah, works. Yeah, works. How much is it? 2 into 9, 10, 10 to the power r minus 1, r plus 1 minus 1, 10 r minus 1, 9, 2 into 10 to 10 power r plus 1 minus. Yeah, this works. This works. You can solve it like that also, but actually the thing is, you should not have to generate all the substrate, like possible palindromes. Because as you can see, for like 1 plus 2 into 10 to the power, it will be something like 2 into 10 to the power r plus 1, something like this. Order of, like it's a exponential number, right? Generating all of these. You can't solve it with 10 to the power 18, right? So like keep that in mind. Actually, the solution will like turn out to be relatively simpler, but that is like the main idea, the 0 1 pattern that I just showed. Okay, so try that. If you face any issues, we will always like resolve it in the group or anywhere. So try solving D. E you can like leave for now, but if you would like, it is like pretty standard question. You can like understand it. So if you guys don't have any other doubts, we can end today's session. Welcome.